Hello everyone, I am Lokesh, a mechanical engineering student from VIT Chennai. Today I am going to discuss about ALDEP and CORELAP, that is associated in the industrial engineering. So in this presentation we'll be discussing about the two important computerized layout design algorithms, that is ALDEP and CORELAP. These two algorithms are used to generate efficient and effective layout for a variety of facilities, including the factories, warehouses, and even offices. Okay, we'll move to the ALDEP introduction. Yeah, we are going to see about the introduction to ALDEP. So, ALDEP is a construction algorithm and it stands for the Automated Layout Design Program. Yeah, ALDEP is a construction algorithm that builds a layout from scratch, as I mentioned here. So, this means that it does not require an initial layout to be provided. There is no need for initial layout. The input to ALDEP is a set of departments and their relationships. As I mentioned here, the relationships between the departments are represented in a matrix called an adjacency matrix. The adjacency matrix shows which department need to be close to each other and which department do not need to be close to each other. ALDEP uses a special technique called anchoring to place departments in the layout. This anchoring is a process of fixing the location of a department in the layout. Once a department has been anchored, it cannot be moved. That's why it is anchored. Like that, anchoring is already is mostly used in the ships. That is, it is used to stop the ship. Same way here, when the department has been anchored, it cannot be moved. ALDEP iteratively places departments until all departments have been placed, as I mentioned here. Yeah, basic data. To create a ALDEP, that is layout design of a ALDEP, we need to have some basic data. First one is total number of departments and the area of departments, layout dimensions, closeness relationship among departments that even has closeness rating, and total number of iterations. So if you see there, if we are coming under the areas, layouts, and total number of the departments, these are the basic data that need to be required for the layout design. So next. So these are the closeness rating. There are many closeness notations which stands for several conditions and it has some values. So for example, here A is A which stands for absolutely necessary, that is 4 cube, that is equal to 64. E stands for the like excellent, that is 4 square is equal to 16. I stands for important and O stands for ordinary, U stands for unimportant, X stands for not desirable. These are the closeness rating. I have given an introduction or the basic ALDEP layout design, and we'll move to the CORELAP layout. Yeah, now we are going to see about the introduction of CORELAP. What does CORELAP stands for? CORELAP stands for the Computerized Relationship Layout Planning, as I mentioned here. So this means that uh, it is a pairwise exchange algorithm uh, that improves an existing layout, as I mentioned here. It requires an initial layout to be provided, as we discussed ALDEP earlier, there we discussed that it does not require any initial layout. But here, in case of CoreLab, we need an initial layout. The input to CoreLab is a layout and a relationship matrix. The layout is represented as a set of coordinates for each department. The relationship matrix is same as the one used by the ALDEP. As I said earlier itself, ALDEP and CoreLab are very much similar, but there are some comparison and there are some difference that we will be seeing in the upcoming slides. Yeah, CoreLab iteratively swaps pairs of departments until no further improvements can be made. Yeah, as I mentioned here, and then a swap is considered an improvement if it requires the total cost of the layout. The cost of the layout is a sum of the distances between all pairs of departments that need to be close to each other. The algorithm stops when the layout converges to a local optimum, as I mentioned here. Okay, we'll move to the next slide. So these are the CoreLab layout design, and we are having different methods, that is construction type algorithm, that is graph based method, adjacency based method, closeness values based methods, that is we are having say several closeness rating, which is our stands for some conditions and the statements, and then selection of the departments is based on the total closeness rating, TCR. Total closeness rating for a department is the sum of the numerical values assigned to the closeness relationship between the department and all other departments. So these are the ALDEP and CoreLab comparison. So if you see the type of algorithm we use in the ALDEP is construction algorithm, and in CoreLab we use pairwise exchange. And if we go for the input, departments and relationship for ALDEP, and layout and relationship matrix for CoreLab. Output is layout. CoreLab is improved layout. That is more number of iterations and more number of updations. So it's an improved layout. And performance, which is for ALDEP, is very fast, but it takes time or it is very slow in terms of CoreLab. And convergence is the for convergence we can say ALDEP is guaranteed and CoreLab is not guaranteed. Yeah. And then I'll give a summary of this comparison, that ALDEP and CoreLab have different strengths and weakness. ALDEP is faster than CoreLab, but it is not guaranteed to converge to the best possible layout. CoreLab is slower than ALDEP, but is guaranteed to converge to a local optimum. So the choice of which algorithm to use depends on the specific application. If the layout problem is small and the time constraints are tight, then ALDEP may be a good choice. If the layout problem is large and the time constraints are not tight, then the CoreLab may be a better choice. Okay. Yeah. So we came to the conclusion. Uh, in conclusion, we can see ALDEP and CoreLab are two important computerized layout design algorithms. These algorithms can be used to generate efficient and effective layouts for a variety of facilities. The choice of which algorithm to use depends on a specific application. Which application we are going to use, that matters. The choice of which algorithm to use depends on the specific application. That is, whichever application we are opting to do, like the layout, plan, design. So thank you.